Hello everyone. Qubes OS is, or also called a reasonably secure operating system, is arguably one of the best security oriented operating system, together with maybe Tails, Unix, and some other. I personally use it and tested it, and more than a year, and I could say it's working amazingly well. Basically, also the full project is very well designed. The documentation is amazing. You could find out anything and everything what you need. This video though is not about the Qubes OS. The reason for this is since we are at the stage where we practicing and we work with the cryptography. I would like to discuss a little bit the digital signatures in terms of Qubes OS. Since once again I explain you the documentation is very well done and everything is really nice organized. The team of Qubes created an amazing work with all the signatures and all additional files you need to be able to check if the system you download will be the closest to the promised template, let's say. So if you click here on I'm gonna provide you of course with the Qubes OS. So once you go and click on the download and install from the main Qubes OS site, you would see the latest release, which is Qubes OS 4.1.1, and you're gonna see immediately the ISO file or download it through the torrent, and afterwards you will find out the way to download also the cryptographic hash values, okay, for the ISO file and for the torrent. Detached the PGP signatures, okay, as well as Qubes release signing key. And also you could see how to verify the download and further guides over there. So that's what we'll do. I will download the ISO file. I'll open my Debian computer, which I already created linked clone from. I don't need for this exercise full clone. I just changed the MAC address. It's pre-installed already, so this is how I call it, Debian 11 for Qubes OS. I'm just gonna check if I have everything needed here into the settings of this virtual machine. I'll be sure that I have access to internet and it will be working fast. So actually I'm gonna go a little bit further and I'm gonna choose 4 GB of RAM here, and I'm gonna choose 2 processors just to be sure that it will be faster. Yeah, that's for graphical interface fine. Network, not networks, fine, and I'm sharing my downloads folder from my physical computer, so that's fine. Let's start this computer, and then through this I will open the downloads folder from my physical computer's browser, and I will put it within. And then I'm gonna use my user and my password, and I'll log in. And basically that's it. From this moment on, I could start downloading the Qubes. So I'll click on the application menu. I'll go to web browser and I open it. As you see, the guest edition has been already implemented here, so I will be able to copy and paste from my real computer to my virtual one and vice versa, as well as I might need to update my guest edition to this specific machine to the newest version, because I recently upgraded the VirtualBox. That's fine. So far I'll leave it like that. So I'm gonna right click here and I'll say paste and go. And I'm gonna go to the downloads. So I'm gonna go a little bit below and I'll download the ISO file. So I'm gonna click on it and the download will start. Okay, so I'm installing it directly on the directly within the virtual machine, and at any point I could actually start checking using the terminal here. I might start checking all the hashes signatures which are related, so to be sure the file I just downloaded or will download any moment is not tampered with. Nobody was playing with, and that's the original. So let's see how it works. We'll wait a little. Now the file has been downloaded already. The rest of the files which we want to download, of course, will be the ones which will prove that this is the file we need. So let's go and let's download the rest. So I'm gonna download the cryptographic hash values. I'll download the detached PGP signature and the qubes release signing keys as well. So let's go and see all the downloads. And if we open our file system, well, actually we need to open our home here. And of course we could go to our downloads folder and we'll see all of these files downloaded. Okay, so everything what we need to prove the ISO file is the one which we need is there. Now there are several good reasons why we may want to generate a hash for some of our data, obviously. These reasons might be for the file integrity to be proved, also password to be verified, and of course the digital signatures to be verified as well. Now the digital signatures in general can prove both authenticity and integrity, and that could be done to a reasonable degree of certainty. As we know, authenticity ensures that a given file was indeed created by a person who signed it. So that means that a third party obviously didn't forge it. Integrity ensures that the contents of the file have not been tampered with. That means that a third party has not undetectably altered its content while file was en route. Now, it's very important to understand that the digital signatures cannot prove that the signed file is not malicious. Okay, well, there is no chance this to be done, since me as a programmer, let's say if I create a program and I put a backdoor, or I put a malicious software inside or malicious code inside, which will create a remote access, a RAT will give remote application to be able to access remotely your let's say servers. Well, this code is malicious, and my signature will prove that I created the code, and I might say at any point that this code there is no malicious part of it, but it could still have it, right? So you need to believe to the person that wherever he or she claims that is a good one and not tampered one, or a clear one without any malicious software, it is exactly what it is. In other words, you need to decide who will be trusting, right? That might be Microsoft, or that might be Qubes project, or that might be somebody else who know. And we need to assume also that if a trusted party signed a given file, then it should not be malicious or buggy. Now, the decision of whether to trust any given party is beyond, obviously, the scope of the digital signatures. This is, you cannot prove this if you don't believe the person itself. Now, as a matter of fact, the public key infrastructure tries to work with. When we decide to trust to certain parties, the digital signature will be very useful because they will make it possible for us to limit our trust only to those few parties we choose, and not to worry about the bad things that can happen between them and us. So that means once we believe the qubes programmers that the qubes OS is these are the people who created, so then we need to be sure, and when we check the integrity of the keys, so we need to be sure then we need just to have a proof that really these people who we trust already are the people who issue the software. Another very important point here is that we to decrypt the hashes, we need the public keys. So we must be sure that the public keys we use for the signature verification are the original ones. The example we're going to use the openpgp standard, since that's the one which the programmers of qubes OS are using. And of course there are such programs which might be used on Macintosh, that's the GPG suite. On Windows you could use GPG for Win, and in Linux, which will be my case, I will use the GNU. If you remember also from the public key infrastructure, there are hierarchy there, which basically is the hierarchy of trust, and it starts with the root. Now, most of the qubes OS projects, because it's not only a single project, there are many of them. These are the ISO files which are changing with the release versions. Repositories they're using, the Git objects most probably. All of these are digitally signed by an official team member's key, or also by a release signing key, also known as a. And such a one we already done. All of these signing keys in turn are signed by the qubes master signing key, or it's also known as a QMSK. There is a hash symbol for it as well, which you could always check. And as a matter of fact, QMSK is the ultimate root of trust for the qubes OS. So the qubes master signing key, or the root signing key, there is no expiration of it. There is no expiration date. It has been generated and it is kept only on a dedicated air-gapped vault machine, and private portion of it, because obviously these are keys and they have private and public portions. So as you remember, whenever you're creating keys like that, the private portion stays with you and you don't share with anyone. So hopefully this private portion will stay like that forever, right? So that means the ultimate trust, which is the qubes master signing key, will always exist in the proper hands, right? So basically, having this, we might start with this. We might actually find out the other signing keys, which are developer signing keys, which are set to expire after 1 year. So they will be renewed after a year. If you remember, reissuing and reusing of the keys in the overall concept of the encryption is not really, it's not really something we need to keep for a long period. So from my downloads folder where I am, I'll right click and I'll say open terminal here, and it will open the terminal within the downloads folder, so I will be able to access directly all the files there. Now, by the way, I installed a program which is called Terminator, which is a program. It's a multiplexer. Just a second. Yeah, this is a program which is called Terminal Multiplexer, which, as a matter of fact, allows you to split horizontally, split vertically if you want to your screen, and work in a different of this. It's something like Tmax. That's the most well-known program actually for this type of thing, and that's my default program here to be used when I'm gonna work with my terminal. So first of all, I need to check if I have the open GNU PG key or GPG2. That's what I need to check. So I could do GPG 2 -- version. Well, it says it cannot be found, so I could say apt. Well, actually I'm gonna change to a super user, so I'm gonna say su. I'll put my password. So if I want to stay in the downloads folder though, I need to execute su without dash, and then I will be still in the home of the user and in its downloads folder. So what I could do here is apt search GPG2, and I could find out the name of this software. Okay, so I could install it. So I could say apt install -y, and I'll use the GPG2. As a matter of fact, it is GNU PG2. And it will be installed. Now I could repeat with up arrow again some of the previous commands, and I could basically see the version of the software again. So I'm gonna say GPG2 -- version, and sure enough it will show me now what is the version. It will actually show me the supported algorithms, the ciphers, the hash which will be supported. Now you see the one it has been discussed already, which is used in Bitcoin. Also compressions, which will be supported, right? So this will be the one we're gonna use for further. Now I downloaded all of these keys, including the qubes master signing key. I will provide all of this key with the comments of the video, so you will be able to get there. The only thing you need to see again in the comments, the link and download. Another very important documents here will be the qubes master key's fingerprint, which will actually prove that all of this which is related with the qubes master key is authentic. So here it is. When you open it, you will see the public portion of it, right? So that's the one which we. So as we mentioned, the public portion of the fingerprint will allow us to create the utmost trust to the qubes site, and we will believe on it if this fingerprint will match. Okay, so the qubes master signing key will match. Now there are a lot of options here which they provide. You could go to some mailing lists, discussion forums, social medias, websites, and so on and so forth. You might even go and check old versions of qubes OS you might download from different than the site which is provided here, and so on and so forth. There are many ways. So let's double check some of this. So what you need to do is just copy this link. Well, you need to try to copy it. And then open the browser and insert it there. So that's the Twitter of qubes. Okay, it has here it shows the fingerprint. So what you could do, you might just come here and you might check it, right? So if that's the same one, you check every one of these digits, and if all of them are okay, as far as I could see, that's what it is. Well, that's the fingerprint, right? So, and it's there we have a match, which means it's something we could believe. But if we're not sure about that, we could always click again and download more, open another site, which is qubes discussion forums, let's say this time, and basically you might see if this is the same one. Here it is. So that will be the way you will create the trust with them by validating the cube's master signing key. Here it is. It's shown. Well, you might go to the social media. Again, click here, right click, paste and go, and check there. Here it is again. So this is the Twitter account of Joanna Rutkowska, which is the co-founder of and the creator of qubes. So you could see by her own words if that's the master key, right? You got the public portion once again of the master key. You might go and check figure by figure, and you might go and check many more, and at a certain point the trust will appear. So you will start trusting, and the root signing key or the master signing key will be the one you will use to prove. Once we prove that's the master signing key which we're looking for, now we need to import this and put it in the trust level of ultimate. Okay, so the command for that will be the so I added this command already here to the to the file which I'm gonna share, and here it is in my terminal. I'll click enter, and it will be imported. Okay, after this command it will be imported. You see, the name of the key is Cube's master signing key. Well, we cannot ultimately trust, but that's why edit the key. So I'm gonna click on that, and yeah, it will say that expires never, that's the short version of it, right, and so on and so forth. Okay, it once again says Cube's master key. Now, as you see, we are in the GPG tool now. So what we could do is to find out the fingerprint with the FPR command. Okay, it will give the short version of it, and it will give the fingerprint as well. So we might come and check it back again. We might say that we trust this one, so we're going to use the trust command. And now I trust ultimately, that's my decision, so I'm going to choose 5 here. Now click enter. Okay, and it's asking me, are you really want to trust this key? Well, I check already everywhere and I believe this guy, so I'm gonna say why. I'll click enter, and afterwards I'll use Q to go out, right? So I'm gonna go out of this. So this is the way we added the key to our chain, to our trust chain. So I could actually check again. I could do the check towards the key which I just introduced. So I could do GPG 2 again, -K option, and I'm gonna look for qubes. It should be with capital letters. Master signing key, and in inverted commas, as you could see. And once I click enter on that, if everything is fine, I should see again the master signing key and its name. Okay, so that's kind of that is kind of a reverse check of what we will be doing. Okay, so this is how we create our trust to the to check the next keys, which are the release. Here it is, the release signing keys. We use a similar option. We need to import them, right? And I already copy it into the document, as well as in my in my command line. So most probably here there is a error. Qubes release. So let's see. Most probably here there is an error. Click tab to find it. Yeah, it's 4. That's what it was. The error. Here it is. It's finding out the key itself, and it says qubes OS release for signing key. And for sure, we might make a reverse checkup again by using this command a little bit up. Yeah, this one. GPG2 check signatures of qubes OS release hex signature key. Well, we need to check to change X to 4, obviously. And here it is. Now again, I could have the public portion of this key, and let's open it. And that's the public portion of I could use a similar command to make a utmost final sanity check. After checking the authenticity, or after adding the qubes master signing key as ultimate trusted root signing key, and afterwards checking the signatures of the qubes OS release signing keys, and in that case, once again, it's about release 4. Okay, it's this is file. Now we have the file of .iso.digest, and that would be the file which will help us to check the integrity of our the cryptographic hash values of the qubes ISO. Okay, so that will be. Now if we open the digest file here, and you open with the text editor, here you're gonna see that the hash which is used is SHA-256, MD5 for SHA-256, and here where the PGP signature starts and when it finishes. All right, so it says here also the qubes ISO file and some of the additional ones with the cryptographics try to see if it will work. So we will use the MD5 sum here, MD5 sum command, and I'm gonna use it with an option of C. I will choose the digest file here, so qubes .iso digest. OK response here tells us that the hash value for that particular hash function is matches, but I need to do some other checks. I need to check with SHA-1, with SHA-256 and SHA-512 sum. So let's do all of them. So I'm gonna repeat this command, and instead of MD5 sum, now I'm gonna choose SHA-1 sum. Again, this confirms as well. Now we'll choose the SHA-256, so I'm gonna repeat the command, and instead of 1 I just gonna check with 256. And lastly we'll try with 512. So I'm gonna change the digits here to 512. Oops. This one confirms too. Now the 23 lines which shows that improperly formatted are okay, they're expected. Because the file contains some lines from several different hash values, but each dot sum or star sum program verifies only the line for its own hash function. So actually that's just something which is expected. Now if you are able to use the OpenSSL with that, let's try to see. We could actually confirm with OpenSSL as well. And in that case we're gonna use -md5. So let's see the command open SSL digest, so dgst, and dash, we're gonna choose md5 again as an initial part of it. But well, actually what I need to choose here now is the ISO file, so I'm gonna repeat this command and I'm gonna use only the ISO file. So that's the one. And it will produce the expected. Now wherever you need here actually, so you need to remove the columns if you would like to see it in a proper way. Now if we would like to verify the signatures of the digest file, actually the last one will be GPG and -v verify, and that would be qubes, and that would be again the digest file. And we see that we have a good signature from QubeSOS release for signing key. To verify the QubeS ISO, the first one which we saw was the cryptographic hash values. The other one is with detached PGP signatures, and this is related to this QubeS -R4, that's the release version 4.1.1, and the .iso file, this one here. So the way this is executed and it is done, we have also similar to it an ASCII file. So here how we could do it, we could repeat the last command which we did to verify, and in that case instead of writing the cubes themselves, so we will write the other one. We will write down the cubes dash R4. Well, that's the ISO. This is the ISO file again, and then well, I need here actually the .aec file. Mistake when I was putting the file. It's .iso.asc, so you click enter. It will take a little bit of time again, and if everything is fine, we will see again that the signature from qubes release 4 wherever signing key is a good one. After 20-25 seconds, here it is, we have a good signature. So you see the way of verifying is not really straightforward. Even though the hashes, you know, shouldn't be, they cannot be changed. First, you need to have the utmost trust relationship, so you need to trust absolutely to the person or the authority will issuing this signing keys, and afterwards you need to check the releases and the ISO itself. So all the commands which I use, I will put in the document, and I will send it in the comments here.